All right, if you're doing Leaving Cert Chemistry, then this is for you. We are going to break down piece by piece the chemistry and practice investigation. You know, the huge project that makes up a massive chunk of your final grade. Let's just dive right in and figure out what you need to do to absolutely nail it.
First things first, let's talk about why this is so important. This one single project is worth a whopping 40% of your entire grade. That's 200 marks just waiting for you. Honestly, it's a huge opportunity to bag a ton of marks before you even walk into that final exam hall.
So, how do you actually get those marks? That's the big question, right? Well, that's exactly what we're going to do here. We're going to walk through the official brief step by step and give you a really clear, simple roadmap to follow from start to finish. Okay, let's start at the very beginning. What exactly is this investigation they're asking you to do? So, its fancy official title is the Chemistry and Practice Investigation. And really, it's a mix of doing your own research and then getting hands-on in the lab with an experiment. This project is where you get your coursework grade, and the other 60% of your final mark comes from that written exam at the end of the year.
Now, this might just be the most important date in the whole document. Seriously, circle it in your journal, highlight it, set 1,000 reminders on your phone. Everything has to be finished and sent to your teacher by Friday, April 23rd, 2027. And trust me, there are no extensions.
Okay, so what are you actually going to be investigating? Well, the good news is you don't have to invent a topic from scratch. The State Examinations Commission, or the SEC, has already set a specific topic for every single student. Your whole project, everything you do, it all boils down to this one mission. You need to investigate how to control the speed of chemical reactions. You'll be looking at what makes them go faster, what makes them slow down, which is, a super important concept in pretty much everything, from making new medicines to designing better batteries.
And you're not just thrown in at the deep end. The brief gives you 5 different factors to pick from. You could look at concentration, surface area, temperature, pressure, or how a catalyst affects things. Now, here's a little tip. Have a think about what your school's lab can realistically handle. Things like temperature and concentration are usually pretty straightforward to control and measure. Pressure, on the other hand, can be a bit trickier. It's your call, so just pick the one you think you can really do a great job on.
Look, a project this big can feel, well, pretty overwhelming at first, but the brief is actually really helpful here. It breaks the whole thing down into a super clear 6-stage roadmap. Let's take a look at how these stages give you a simple path from start to finish.
So here they are, the 6 stages that'll take you from a blank page right through to a finished project. You start with your initial ideas, then you dive into the background research. After that, you'll design and plan your experiment, and then of course, you actually do it in the lab. The last 2 steps are all about analyzing your data to figure out what it all means, and then you pull it all together in your final report. See, it's a really logical process. Okay, before you write a single word, we have got to talk about the rules. The formatting for your report is super strict, but I want you to think about it this way. These are some of the easiest marks you are ever going to get. You just have to follow the instructions. The big number you need to burn into your brain is 1,500. Your report cannot, under any circumstances, be more than 1,500 words. But here is the fantastic news. That word count does not include your reference list, your data tables, any chemical formulas, or the labels on your diagrams. So you can use those 1,500 words purely for explaining your work and your analysis.
And when I say the rules are specific, I mean they are really specific. Your section headings have to be Arial size 14 and bold. The main text is Arial size 12 with 1.5 line spacing. Your pages have to be portrait, not landscape, and they need to be numbered at the bottom center. And you need exactly 20mm margins on all sides. Honestly, my best advice, just set up your document template with all these rules on day 1. Then you never have to think about it again.
And the formatting rules don't stop there. When it comes to editing your text, you can use bold, italics, and bullet points to keep things organized. But what you absolutely cannot use is any colored text, no highlighters, and no other fonts. It has to be Arial and only Arial. The goal here is to keep it looking clean, professional, and consistent. So, your report is written, it's perfectly formatted, it's basically a masterpiece. Now you've just got one last hurdle to clear, the submission and authentication. Let's do a quick run-through of how you get this thing over the finish line. Here is your final checklist for submission day. First, you'll convert your final report into a PDF. And I am telling you, please print that PDF copy and do one final proofread. You will spot formatting mistakes on paper that your eyes will just glide over on a screen. After that, you submit the digital PDF to your teacher, you sign an authentication form to say the work is yours, and that's it. Your school handles sending it to the SEC. It's as simple as that. Now I'm going to read this next part directly from the official brief, and it is incredibly important that you hear this. It says, to include material that is not created by the candidate and not properly referenced will be considered plagiarism. This is considered cheating. Let's be really clear here. Using anything that isn't your own work, from a book, a website, even from an AI, without referencing it properly is cheating. The consequences are really serious, so you have to take this part of the project very, very seriously.
So what does this whole authentication process thing actually mean? Well, it boils down to something really simple. You have to prove that the work is 100% your own. And the way you do that is through meticulous referencing. Every single source you use, every fact, every idea that wasn't originally yours has got to be cited.
All right, we've covered the what, the how, and the when. Now it's time for the part I'm sure you've all been waiting for. How are you actually going to be graded? How do they divide up those 200 marks? Okay, so those 200 marks are broken down neatly into 4 sections called A, B, C, and D. And the most critical thing to understand here is that they are all weighted equally. Each section is worth 50 marks. That means every single part of your project, from your very first bit of research to how you communicate your findings, is just as important as the others. Let's dig into that a little bit. Section A is all about your title, your introduction, and your background research. Section B is for how well you design and then actually carry out your experiment. Section C is for your data, how you analyze it and the conclusions you draw from it. And finally, Section D is for scientific literacy and communication. This is where all those strict formatting rules, your clear writing, and your proper referencing all pay off. It's basically about how well you present your work like a real scientist would. So, to wrap this all up, here is your final checklist for success. First, make sure you really understand the topic of reaction rates. Second, follow those 6 project stages one by one. Third, obey those formatting rules to the absolute letter. Fourth, submit everything correctly and on time. And finally, above all else, prove that the work is 100% your own. And that is our tour through the Chemistry in Practice brief. Your entire investigation is about controlling the speed of reactions. So I'm going to leave you with this question. What is the very first step you're going to take today to accelerate your own path to success in this investigation?